Hello everyone, I'm Zhang Teng, a student from the Academic of Information Science and Engineering, Dalian Polytechnic University, major in Electronic Information in 2020. The title of my thesis is A Novel Solar Glass Window with Photovoltaic Power Generation and Automatic Temperature Regulation and Dust Removal Functions. My tutor is Wang Jinpeng. As a new type of clean energy, solar energy has many advantages that traditional energy does not have, and its current applications are gradually widespread. Therefore, the original intention of this design is to combine the technology of using solar energy to generate electricity with the windows in the building to improve the shelter indoors in summer and reduce energy waste. This solar glass window has three main functions. They respectively are solar power supply, intelligent temperature control, and automatic dust removal. My thesis is divided into 6 parts. They were introduce, system overview, function principle, experimentally analyze, conclusion, and references. In social today, energy has become a hot topic. Fossil fuel as a traditional non-renewable energy source is still one of the major energies on which we depend. Building energy is an important portion of total energy, accounting for about 40%, which consumes a large part of fuel energy. This problem shall never be ignored. Solar energy is a renewable energy with multiple advantages. A main way of generating power from solar energy is photovoltaic power generation. By combining windows with PV power generation, part of the energy increase can be avoided. The Losaki experimentally solar house in Japan is important. However, this paper does not consider the form of photovoltaic power generation combining multiple functions and did not provide an exact solution for dust, an important factor affecting the photoelectric conservation rate. Compared with incomplete power generation function, the novel solar glass window in this paper realized the intelligent temperature control while supplying power to indoor air conditioner and automatically control the turn on and turn off of cooling equipment according to the indoor temperature. However, the dust accumulated on solar energy panel can reflect, scatter, and absorb solar radiation to direct the transmission of solar radiation. So the output power decreases accordingly, which severely affects its photoelectric conservation efficiency. In order to solve the problem of low photoelectric conversion efficiency due to dust accumulation, the solar glass window is equipped with photoelectronic thinner and dust removal device, which involves functions and automated dust removal according to the dust accumulation on the solar energy panel. The picture on the left is the front view of the design, and the picture on the right is the cross-sector side view of the design. It can be summarized as the following. The first point is installing solar panels of appropriate size on window frames. The second point is adopting the double layer glass structure, combining the semi-spread flexible thin film solar cell on the outer glass. The third point is there are some small holes drilled in the upper and lower parts of the outer glass. The last point is that the A photoelectric thinner and dust removal device are installed on the outside of the window frame. The picture on the right is a schematic diagram of lowering the room temperature. The outdoor air enters the air between the two layers of glass through the air inlet under the outer glass. The photovoltaic power generation system is mainly divided into three parts: power generation system, power storage system, and inverter. The power system consists of flexible thin film solar cells and solar panels installed on windows frames. The power storage system includes a photovoltaic controller and a battery pack. The inverter converters is a direct current for used by indoor air conditioners. In order to complement the utilization of the whole photovoltaic power generation system, it's very important to calculate the conservation efficiency of the inverter and select the inverter with suitable specifications. The formula for calculating the important power of the inverter is Formula 1. Formula 2 is based on KLC to obtain the current generated by the photovoltaic cell. It can be further calculated to get Formula 3. In the case of an open circuit, the open circuit voltage of the photovoltaic cell is shown in equation 4. In practical applications, ISH and ID are generally ignored, so we can get Formula 5, 6, and 7. The temperature difference delta T and the light intensity difference delta S can be set as shown in equation 8 and equation 9. Finally, the values of C1 and C2 can be determined, and the current and voltage generated by the photovoltaic cell can be obtained as shown in equation 10 and equation 11. The formula for calculating the output power of the inverter is shown in Formula 12. The conservation efficiency of the entire system can be obtained by dividing the AC power and the DC power as shown in equation 13. The picture on the left is the analyzed diagram of the energy of the outer glass. When the sunlight hits the outer glass attached to the flexible thin film solar cell, the energy is divided into 4 parts. The picture on the right shows the heat exchange diagram between the inner glass and the surrounding environment. In summer, due to the limited cooling capacity of this design, it is necessary to turn on the air conditioner to cool down, so the thermistor is selected as the temperature signaler of this design, which can automatically turn on and off the air conditioner according to the indoor temperature. The resistance calculation formula of the thermistor is shown in equation 14. Take the natural logarithm of both sides to get formula 15. After transformations, get formula 16. It can seem that ln RT has a linear relationship with T1, and the slope obtained by the linear 15 is the B values of the thermistors. The formula for B values is shown in formula 17. The schematic diagram of the circuit that uses solar energy to power the air conditioner is shown in the modified figure. It not only has automatic model, but also manual and timing model. The last function is automated dust removal. Whether the dust on the solar panel has been dealt with in time is a problem that cannot be ignored. If it is not dealt with in time, the whole system will fall into a vicious cycle. The new solar glass window design in the paper has an automatic dust removal function. The figure below is a schematic diagram of the automatic dust removal system in the design. It's mainly divided into 4 parts. This is a circled schematic diagram of the automatic dust removal system. The photoelectronic similar selected in the design is E3FDS306 adjustable diffuse reflection photoelectronic switch. It has the following advantages. The TL084 chips has the advantages of small size, low power consumption, high conservation efficiency, low base cost, and strong anti-interference. The figure below is a schematic diagram of a amplifying circuit. Amplifying signal is not a standard square wave and needs to go through a shaping circuit. The figure below is a TTL shaping circuit with LM311 as a voltage comparator. After amplification and shaping, the signal is transmitted to the MSP340 MCU. The following figure is a schematic diagram of the power supply circuit. Choose LM2576 voltage and stabilizer and LP2985 voltage stabilizer. The figure below is a schematic diagram of the drive circuit. The dust removal device is composed of brush head, DC motor, and filter bag. Brush head is used to describe the dust. DC motor is used to drive the brush head, and dust filter bay is used to store dust particles. Dust removal efficiency can be calculated by Formula 18. And the calculation expressions of C1 in equation 18 and shown in equation 19. The next part is the experimental analysis part. The picture below is a physical picture of the new solar glass window. The picture on the left is a picture of the indicator light of the solar controller lights up when the light is insufficient. The solar controller selects the normal open model. At this time, the charging indicator light is off, but the load indicator light is on, and the battery supplies power for the small fans. When it's placed in the sun and the sunlight is insufficient, the charging indicator and the load indicator will all light up. The solar panel and factor thin film solar cells generate electricity to charge the battery. At this time, the light of the indicator light is shown on the right picture. Its specific performance and values are shown in the table. We can see that the photoelectric conservation insufficiency still needs to be further improved. The novelties of new solar glass windows can be summarized as the following 3 points. The factory thin film solar cell combined with the outer glass and the solar panel installed on the window frame can generate electricity at the same time. Intelligently control the on the off of the air conditioner according to the temperature signal. slowing the problem of wasting air conditioner air energy consumption. An atomic dust remove device is installed on the outside of the glass window to improve the photoelectric conservation efficiency of the entire system. These are the references for this paper. Thanks for watching.